Good afternoon. I would like to spend the next few minutes to go with you over some thoughts on what the European Commission work was all about in the time frame 1991 2009, where we moved or we tried to move towards mobile internet. When I look back at the trajectory of mobile communications field during my presence at the EC, I find it interesting to reflect on how we, first of all, moved from a multiplicity of incompatible systems in the pre GSM days to a single 5G standard today. My first job as I entered the Commission in 1991 was one of project officer of Project R1043, where R stood for RACE, Research in Advanced Communications in Europe. It was a project, it was one of a series of projects of mobile nature that aimed at propelling Europe to a leadership position worldwide. Now, participants were basically all of the main industrial components of the time, namely Ericsson, Nokia, Alcatel, Thomson, Bosch, Thorny, Mai, Rockmanner Research, GC Marconi, and Philips. There were representatives from universities, namely Karlsruhe, Strathclyde, and Bradford. The operator world was included in the project with the presence of British Telecom and the Greek operator OTE. Now, the project introduced the concept of a successive series of mobile services or generations of mobile services. Analog systems such as AMPS, those days, or Germany MATS, or the Nordic NMT system were considered as first generation. GSM, as a single digital technology solution, was aiming at providing Europe with a pan-European solution where users could roam from one country to the other, and as such, it was considered to be a second generation system. UMTS was, with its broadband capability at 2 megabits per second and its mass market orientation, a system considered to be third generation. Coincidentally, with the creation of UMTS, the ITU, namely the International Telecommunications Union, were taking recommendations on the next generation mobile systems, and the program in those days in the ITU circles was referred to as FLUMTS, FPLMTS, Future Land Mobile Public Telephone System. It was primarily directed at identifying and producing recommendations for the harmonization of mobile spectrum allocations worldwide. By 1992, it was clear that the work of RACE had to continue to ensure industrial exploitation of the concepts that had been developed so far. This was particularly obvious further to the first RACE mobile telecommunications workshop that took place in Nuremberg in 1992. Extensive research activities were planned to evaluate the market and technical requirements, as well as the physical implementation aspects of UMTS. UMTS had at its aim to provide a multitude of communication services, ranging from speech to video telephony to high data rate file transfers up to 2 megabits per second, with quality, of course, comparable with that of the contemporary fixed network. In those days, we experimented with Project Coded, which was in charge of looking at code division and multiple access, Project ATDMA that looked at time division and multiple access. But there were other projects, such as Tsunami, which looked at smart antennas and considered the benefits that adaptive technologies could have to bring to be used for. The mobile network dimension was looked at in terms of network management and security by a project called MONE. And finally, a project called MAVT, Mobile Audiovisual Terminal, evaluated different source and channel coding techniques for low bitrate image and speech transmission for future mobile terminals. Apart from UMTS, we had a project called MBS, Mobile Broadband System, that investigated requirements of very, very high bitrate transmission using millimeter wave technology. In the period up to the end of race program in 1995, annual conferences took place and brought together the best industrial and academic brains of the time. The first instance where a CDMA system was demonstrated publicly occurred in Cascais in November 1995 at the 4th Race Mobile Summit. From then on, Europe evolved from a situation where it clearly had the lead in the development of mobile communications to a situation where, due to the lack of a clear strategic vision of what the future had in stock, European leadership was gradually put in question by others. Starting in the end of 1995, the EC felt that a more ambitious program needed to be set in place, particularly to allow for UMTS validation. Project Frames came about. This was under the ACTS program, and it was commissioned to build two platforms using CDMA as well as TDMA. CDMA was through WCDMA backed by PKI and ATDMA backed by Alcatel. At the time, I was really surprised by the resistance or reluctance of some member states to the gradual moves from 2G to 3G and then later on from 3G to 4G. This was influenced by the operators themselves because some member states saw these moves from 2G to 3G as something that would put in question the economic feasibility of GSM systems. The investment in R&D was felt to be premature since it would draw badly on the resources that was needed for commercial investments. They simply could not understand the speed of change that was occurring in the mobile communications field. Campaign against R&D proposals of the Commission was at times rather brutal, with specialized press being called upon to criticize the insanity of the European approach. Opposition to 3G grew as the possibility of industrial exploitation drew closer. Great fear was that GSM would be displaced. In reality, GSM would only be displaced by its own limits. The improvements in radio technology, allowing high-frequency bands to be used, would open up a vacuum for rival industrial initiatives to fill from other parts of the world. But those still struggling to get GSM on the ground could not see so far ahead. An interesting battle of standards took place in those days regarding 3G development. And EC then was a victim of some mild attacks from companies that were proposing a system called IS-95 because they wanted IS-95 to be adopted as a standard of Europe, which of course was not very well accepted in Europe. In 2001, I was particularly shocked and angry at the situation I had to face when Alcatel announced proudly through its CEO that they were a fabulous company, that is, a company without an industrial manufacturing site. But Alcatel was not a sole example of visionless capabilities on the part of their management. I was also confronted at the time with the pulling out from Philips from the mobile communication business. Suggestion was made that this incident could only be attributed to the fact that at the time the recently appointed CEO of Philips was a US-raised person with little knowledge of mobile communications field. He was clearly incapable not only to understand the R&D that was being carried out in Europe in terms of its collaborative dimension, but also equally not able to and not ready to adapt or to adjust his company in an intelligent manner to worldwide shifts. Many meetings with Japanese, US, and ITU counterparts took place in those days in the context of what was called the famous group, where famous stood for future advanced mobile universal systems. It was a group very unique, where moments of fun and friendship took place, where our ideas across three continents were confronted. And in those days, there was only US, Japan, and Europe. But further to the meetings of famous, other entities worldwide started to show up. To start with with companies from South Korea, who were immediately followed by companies from China, who were eager to learn and benefit from technology transfers. Another interesting point to mention relates to the means employed by some to stall the R&D efforts. This was the case regarding a system called Hyperland, a local area network concept that aimed at connecting and serving terminals much like Wi-Fi. This R&D effort was led by Thomson, with the support of Ericsson, Nokia, Philips, and Sony. Clearly, much better than Wi-Fi and offering quality of service, it was not adequately backed up by ETSI, the European Telecommunications Standards Institute, and as such, lost the battle for success. There were lots of controversial steps taken by some companies to assume leadership of the ETSI process regarding standardization of Hyperland, with the result that by the time a standard had been adopted, the market had already voted for the Wi-Fi technology. While the work on 3G and 4G solutions was taking place, looking at how the internet world was developing became a must. It was obvious to me that the vehicle of choice to access the internet was going to be the mobile handphone or mobile tablet. There was a plethora of situations, numerous cases where indeed this was going to be the case, for instance, in education, commerce, entertainment, transportation, etc. Studies were commissioned to investigate the issue, and surely enough, they concluded that so-called mobile internet was imminent. By 1998, some of our R&D partners were reluctant to accept the world of mobile telecommunications and the fact that it would merge with the mobile internet or with internet world. To consider that the chances of an evolution beyond SMS and MMS were almost non-existent was frankly short-sighted. At the time, I thought that only an innovative company such as Nokia could understand the approach. I hence took upon myself to visit the headquarters of Nokia in Finland. Much to my regret, the management of Nokia, remarkable for their innovation capabilities, listened politely to what I had to say, but could not simply anticipate the emergence of the internet and role it would play in our mobile life. It took a few more years before a change in direction took place, and where Nokia went from a network-enhanced company to an internet-driven company. Very early on, and notably in the context of the Sixth Framework Program, consideration was given to the design and operation of future networks capable of supporting trillions of devices with widely varying traffic carrying needs and capabilities, while still remaining, of course, energy efficient. This included a reflection on how to evolve the internet in light of the fact that it was being used for a large variety of commercial and non-commercial purposes. While the internet was hardly broken, it had proved to be unable to integrate new ideas, new architectures, and provide paths for future integration of data, voice, rich media, with higher reliability. To some extent, it was felt that the Internet had become ossified due to its strong support of numerous activities of our society and the fact that it was not defined with the current division of a business and societal infrastructure. To cope with the problem, the European Commission facilitated the creation of what was called the Future Internet think tank. And they were tasked to provide a position paper that could help frame future coordinated action in this field. The idea was to develop a consistent programmatic approach for the coming years, both from a technological as well as policy perspective. It was indeed felt needed that future activities under the seventh framework program would benefit from a more systematic and coordinated approach in this field. From a new perspective, the approach taken was from the outset to encourage an academic industrial partnership, leading to coherent industrial research roadmaps and partnerships. And that took place through the establishment of what was called the European technology platforms. Today, in all areas relating to the network communications at large, much is still to be done in Europe. If we really want its best researchers to have an opportunity to shape our collective future, strong partnerships and visionary research collaboration agendas with a built-in capability for risk-taking are more than ever an imperative. The age of the algorithm-driven services must be thoroughly questioned if we still aim at European democratic society capable of preserving our privacy and security. The gradual power shift from network-driven concerns to content handling strategies offers an abundance of crucial questions regarding our place in the world. A free information society where the sources of information are reliable and can be scrutinized at all times, where the information circulated on the network architectures is not manufactured or tampered with, and where citizens are not the subject of information filtering are some of the prerequisites ahead. We're still in the infancy stages of a fully connected planet. Much is yet to happen, but we will surely have ample opportunities to drive the changes ahead, regain our competitiveness where needed, and globally shape our future. Thank you very much for your attention.